The lifetime transmission fluid in your car does have a lifetime. It is a lot shorter than yours, and over the next half hour I'm going to show you whose lifetime it actually refers to, what that fluid is physically doing while it dies, what the real change interval is according to the people who built the gearbox rather than the people who sold you the car, and what the whole thing costs either way. No hedging, no maybes, numbers. Here's the thing that started me down this road years ago. A pan off a sealed 8-speed at 96,000 miles on a truck whose owner's manual said the fluid never needed changing. The fluid came out the color of weak coffee. The magnet in the bottom of that pan was wearing a gray fur coat about a 1/4 inch thick, and that fur is clutch material and bearing steel, and every bit of it had been circulating through the valve body for the second half of that truck's life. The transmission still shifted fine. That's the part people miss. It always still shifts fine, right up until the week it doesn't. 3 things I want you to stay for. First, there is a fluid temperature where useful life stops, being 100,000 miles and becomes 25,000, and I'll give you the exact number along with what puts an ordinary commuter car there on a hot afternoon. Second, one major automaker told owners its 8-speed automatic never needed a fluid service and then had to introduce a brand new fluid and a 20-quart flush procedure to stop those same transmissions shuddering. That story has a dollar figure attached to it that will annoy you. And third, there is one specific situation where changing the fluid is genuinely the wrong call, and I'll describe exactly what that looks like near the end, because most people get it backwards in both directions. Let's start with what the fluid actually is, because almost every bad decision in this subject comes from thinking of it as oil. It isn't oil. Or rather, lubricating is about the 4th most important thing it does. In a modern automatic, that red or amber liquid is the hydraulic working fluid that operates the entire transmission. The valve body is basically a mechanical computer, and the fluid is what runs through its circuits and squeezes the clutch packs together at a few hundred psi. It's also the coolant, and it's a friction modifier that the clutch packs rely on to engage cleanly. Sit with that last one. You have a fluid whose job is to reduce friction between gears and bearings, and simultaneously to deliver a precisely controlled amount of grip between clutch plates that have to grab in a couple of 100 milliseconds without banging your teeth together. Those 2 jobs fight each other. The additive chemistry that balances them is not durable in the way base oil is durable. The old hands in the transmission trade understood this intuitively back when every car had a dipstick and a 30,000-mile pan drop written right into the maintenance book. Nobody argued about it. You dropped the pan, you looked at the magnet, you cut open the filter if you were curious, you put it back together with fresh fluid and a new gasket. That was the ritual, and transmissions that got it lasted, and transmissions that didn't get it turned into the thing you're towing. Now here's how the fluid dies, because it does not die the way engine oil dies. The base oil oxidizes. Heat plus oxygen plus time turns some of the hydrocarbon into acid, and the industry measures that with something called total acid number. Based on historical data correlating with shudder tendency and loss of frictional performance, fluid whose acid number has risen by about 2.5 milligrams of potassium hydroxide per gram is considered to be at the end of its useful life. Fine. That's the number the engineers watch. But here's the part that matters to you, and it's the part almost nobody explains. The friction modifiers, which are present in tiny concentrations, can oxidize in the fluid or right at the clutch surfaces without moving that acid number much at all. Read that again. The stuff that makes your transmission shift smoothly can be gone while the bulk fluid still tests acceptable. That's why a transmission can pass every objective measure and still shudder, and it's why the fluid still looks okay is worth almost nothing as evidence. Which brings me to the single most common piece of advice on this subject, and it's wrong. Somebody always says, just check the color, if it's still red you're fine, if it's brown change it. Chrysler's own service information on ATF Passé 4 says the red dye is not permanent, that the fluid will darken and may eventually become brown as a normal consequence of use, that the odor changes with age, and, their words not mine, that color and odor cannot be used to indicate fluid condition or the need for a fluid change. The manufacturer is telling you the eyeball test doesn't work. Burnt smell and black fluid tell you something is already wrong. Clean-looking fluid tells you nothing. Meanwhile, the mechanical side is loading the fluid up with everything the transmission sheds. internal components mesh and wear and create fine metallic particles that contaminate the fluid. The paper filter loads up with those particles, and the fluid goes through thousands of heat cycles and shear loads that deteriorate and deplete its key lubricating properties. That suspended grit is an abrasive slurry running through valve bores machined to tolerances measured in 10,000ths of an inch, where a bore and a valve stops controlling pressure properly, and a clutch that should apply in 1/5 of a second takes a bit longer, and every one of those slightly too slow applies generates heat, which is the real killer. Let's pay off that first promise. By the way, if you drive an SUV and want to keep it reliable for hundreds of thousands of miles without wasting money at the repair shop, I put together a guide called the 500K Mile Car Care Bible. It covers 101 habits that can help your SUV last longer, the warning signs you should never ignore, and how to spot mechanic upsells that quietly drain your wallet. To get your copy, just scan the QR code on screen with your phone's camera or grab it from the first pinned comment below. The rule of thumb the trade has used for decades is that transmission fluid will give roughly 100,000 miles of service at a normal operating temperature around 170 to 175 degrees Fahrenheit, and that above that, the oxidation rate doubles, the useful life halves, for every 20-degree rise. Run the ladder. At 195 degrees, you're down to about 50,000 miles. At 212, the boiling point of water, a number your transmission can see towing a trailer up a grade in July, you're at roughly 25,000. At 235, it's about 12,000 miles. At 275, it's 3,000. And above about 300 degrees, the metal inside starts to warp and distort. I want to be honest about that chart. It has been floating around the industry for a very long time, and I can't trace it to a single controlled study. Treat it as directional rather than gospel. But every fluid chemist and every transmission builder I've ever heard discuss it agrees with the shape of it. And the shape is the point. Heat is not one factor among many. Heat is the whole story, and the relationship is exponential, not linear. Now, what's normal? Most automatics run between about 175 and 200 degrees in everyday driving, and while temperatures rise above 200 when towing, climbing, or driving in hot climates, anything past 200 is worth watching closely. Above 250, the rubber seals start to harden, which gives you leaks and pressure loss means clutch slip, and clutch slip means more heat. It feeds itself. And the cooling system is thinner than you'd hope. On most vehicles, the transmission cooler is a small heat exchanger sitting inside the radiator end tank, sharing its fate with your engine coolant. Testing has shown the typical original equipment cooler is marginal at best. Fluid entering at 300 degrees can leave at 240 to 270, a drop of only 10 to 20%, which isn't nearly enough for extended fluid life. So who's actually generating that heat? You are, probably, and you don't think you are. Here's my favorite statistic in this entire subject. The conditions that cook fluid early include frequent short trips, stop-and-go traffic, gravel or salted roads, towing, and even running a roof or bike rack. A found that while only 6% of drivers believed they were driving in severe conditions, once those drivers understood what severe actually meant, 62% of them were. 6% think it. 62% are doing it, which means the normal service column in your maintenance schedule, the one with no transmission service listed in it at all, is a column most people don't belong in. That's the heat story, and it's the foundation for everything after this. If you're finding this useful, subscribe. This is the kind of thing I dig into every week. Now let's get to the part I promised. What happens when the company that built your transmission and the company that sold you the car say two different things about the same gearbox? Take the ZF 8-speed automatic. It's arguably the best conventional automatic ever built. It's underneath a staggering range of vehicles, and it makes a perfect test case because the same hardware gets sold with two completely different maintenance stories depending on the badge on the hood. BMW called it a lifetime fill with no service interval, while other manufacturers using the same transmission, and ZF itself, recommend a fluid service every 8 years or roughly 50,000 to 75,000 miles. Chrysler's 2017 owner's manuals for vehicles using that 8-speed specified the fluid as lifetime and never needing changing, and didn't even list a severe duty interval for it. Same gearbox, same fluid, same clutches. Two different answers, and the difference isn't engineering. Now here's my honest caveat on the numbers because I don't want to give you false precision. ZF's own published guidance has appeared at different mileages in different documents and for different applications, with figures in circulation running from about 50,000 miles up to roughly 93,000. And the qualifier that matters more than any single number is ZF's own instruction to shorten the interval under high temperature, high load, or unknown service history. When sources disagree, I take the conservative one. So when I quote ZF at you, I'm going to say 50 to 75,000 miles, or 8 years, whichever lands first, and I'm going to tell you plainly that ZF has published looser numbers than that in other places. The rest of the industry is just as split. Ford's 2016 workshop manual for one of its widely used automatics called for a fluid change every 150,000 miles regardless of normal or special operating conditions. Which, worth noting, is a transmission derived from a ZF design and built under license, the same family BMW called Fill for Life, while ZF published a service interval measured in 8 years. Toyota's ATF WS, the WS stands for World Standard, is marketed as a lifetime fluid implying it never needs changing, and shops that see a lot of them will tell you it generally does not stay good for 100,000 miles. The common independent recommendation on those is 60,000 to 100,000 miles. On the CVT side, it's tighter still. Some owners' manuals label CVT fluid lifetime, while transmission specialists put severe use service as early as 30,000 miles and treat routine service as critical as the vehicle ages. And here's a detail I find genuinely funny in a bleak way. Subaru owners in Canada report that to keep the extended CVT warranty coverage, a CVT fluid replacement is required at 5 years or 100,000 kilometers. On a fluid the marketing describes as a lifetime fill. I could not verify that directly from Subaru's own documentation, so take it as owner reported rather than confirmed. But if it's accurate, then the fluid is lifetime right up until the moment the warranty department needs it not to be. Let's talk about what you actually do about all this, because I'm not interested in leaving you with a grievance and no plan. Step 1, find out what your transmission wants and whether you can even get at it. Pull up your fluid specification, not ATF, the actual spec, because Honda DW1, Toyota WS, Subaru CVTF, and similar specifications are not interchangeable. Then get underneath and find out what hardware you've got. A dipstick and a filter under a pan means the factory expected somebody to service it. A drain plug and a fill plug with no dipstick means the factory expected a shop to service it. And on plenty of modern units, there's no dipstick at all. There's an old bit of workshop logic that applies here. If the thing has a drain and a fill point, somebody engineered it to be drained and filled. Step 2, pick the method. A basic drain and fill empties the pan and refills it, which typically replaces about 40 to 60% of the total fluid, because the rest is sitting in the torque converter and the cooler lines. On the ZF 8-speed, a pan drain and refill through the fill port swaps somewhere around 3.5 quarts out of a system that holds substantially more. That's not a failure of the method, it just means you do it more than once, and 2 drain and fills 6 months apart get you most of the way to fresh fluid with none of the risk of a machine flush. Step 3 is the one that catches people, and it's why some shops won't touch these. On a lot of sealed units, the correct fill level is set at a specific fluid temperature, not by volume and not by eye. A thermostatic valve keeps fluid out of the cooler until it's up around 75 degrees Celsius, so you have to bring it up to temperature and then recheck the level. And skipping that step is exactly why somebody's correct fill turns out low later. Underfilled, the pump aerates and starves clutches. Overfilled, the gear set whips the fluid into foam, and foam doesn't transmit pressure. Both are bad and both are self-inflicted. Safety, briefly, and this is real rather than boilerplate. That fluid is at engine bay temperature when you check the level properly, around 200 degrees, hot enough to give you a serious burn through a glove. On some trucks, the exhaust crossover pipe runs directly beneath the transmission pan. On at least one popular half-ton, it sits right under the drain plug, so plan the drain path before you crack anything open. Jack stands always on a flat surface, and if the procedure requires the engine running, chalk the wheels and stay clear of the drive shaft. Now the money, because this is where the whole argument gets settled. A drain and fill nationally averages around $147 in 2026, running from about $80 at a quick lube on a small sedan to $260 at a dealer on a bigger truck, and a full machine flush averages about $232. CVT specific service averages closer to $298. The expensive outlier is the sealed European-style unit where the filter is integrated into the pan. dealer cost on just the pan with filter, and the oil runs over $350. And one owner calling around for a pan drop service with factory fluid and a factory pan was quoted $1,200 all in. Doing that one yourself changes the picture a lot. Aftermarket pan and filter kits for that transmission have sold in the $70 range, and the correct ZF fluid has been available around $16 a liter rather than the $30 plus a quart the dealer parts counter wants. Set that against the failure. The average transmission replacement runs between about $5,087 and $6,297. Repairs in 2026 range from roughly $4,800 to over $6,500 depending on the job. With labor rates past $200 an hour in a lot of the country, and a modern 8 or 10 speed replacement lands around $4,500 to $8,000. So you're weighing 3 or 4 services across the life of the car at a couple $100 a pop against a 5-figure adjacent bill you didn't budget for. That's not a close call. That's not even an interesting question. Now the promised exception, because I don't want you walking away from this and doing something dumb to a car that's currently fine. Here's the situation that worries people. 200,000 miles, original fluid, never touched, still driving. Somebody flushes it and the transmission dies 3 weeks later. Everyone concludes the flush killed it. Experienced mechanics do warn that servicing a high-mileage, never-serviced transmission can trigger failure within a few hundred miles, and the usual explanation given is that debris from worn clutch plates helps those same worn clutches grip, so stripping it out leaves them unable to engage. My read, and I'm flagging this as my read because this is one of those arguments where good texts land on opposite sides and I don't think anybody has published a clean study, is that the grit helps grip explanation is mostly folklore and the real mechanism is duller. A transmission that has run 200,000 miles on original fluid is already worn out. The clutches are thin, the bores are loose, and it's living on borrowed time. The flush doesn't create the damage so much as accelerate the visible failure of a transmission that was already compromised. There's also a genuinely mechanical version of the risk. A machine flush on a transmission past 100,000 miles with no service history can dislodge sludge, plug the filter, and trigger slipping. That one I do believe because I've seen a brand new filter come out already clogged after a service on a neglected unit. So the practical rule is not never touch it, it's this. If the history is unknown and the mileage is high, do a simple drain and fill, drop the pan if you can, look at what's on the magnet, and stay away from the pressure machine. If big flakes or heavy metal buildup come out, you're not doing maintenance anymore, you're doing diagnosis. A little metallic dust is normal. Chunks mean internal damage. And if it's shuddering and slipping already, fresh fluid is not a repair and no bottle of additive is either. Which is the perfect bridge to that second promise I made and to the single best illustration in the modern era of what happens when a manufacturer decides fluid maintenance isn't a thing. GM's 8-speed automatics, the 8L45 and 8L90, went into a huge slice of the truck and SUV fleet. And owners started reporting a shudder, a vibration during light throttle acceleration between about 20 and 80 miles an hour, often described as driving over a rumble strip on smooth pavement. The explanation that emerged is moisture contamination. The fluid is hygroscopic, it absorbs moisture from the air, and when enough builds up, the torque converter clutch can't engage smoothly. So what was the remedy? In 2019, GM issued a technical service bulletin calling for a full flush of the torque converter fluid using a new Mobile 1 LV ATF HP fluid specifically designed to deal with the issue, a procedure that in practice meant a triple flush using 20 quarts of the special synthetic. Think about the shape of that. The fix for a transmission that supposedly never needed a fluid service was a fluid service. 20 quarts of it. More than a dozen bulletins were issued chasing this thing. The flush helped many owners and did nothing for others, and when it didn't work, the next step was replacing the torque converter. Then it went to court, and I'll be careful here to label allegations as allegations. Lawsuits allege GM knew about the problems as early as 2015, and that customers were often told by dealers the behavior was normal for the vehicle. One complaint characterizes the fixes as patchwork software updates and parts replacements that didn't work, and that cost owners hundreds and sometimes thousands of dollars. And the number that stuck with me, according to one class action, GM engineers asked the company to fix the problem for $305 a vehicle, which would have cost around $592 million. That's a claim in a lawsuit, not a proven fact, and I'm not going to present it as one. But if it's even approximately right, it tells you what these decisions actually look like on the inside, not villainy. A spreadsheet. So let's name the thing coming for you, because it isn't a person and it isn't a conspiracy, it's a document. The maintenance schedule in your glove box is not an engineering opinion about how long your transmission can live. It's a warranty document. It was written by people whose job was to define the smallest set of obligations that gets the vehicle cleanly through the coverage period, and their coverage period is not your ownership period. The standard powertrain warranty in this market runs 5 years or 60,000 miles, and even the generous outliers top out at 10 years or 100,000 miles for the original owner only. Now listen to how the transmission builder's own engineers describe the validation standard. These transmissions are tested to 100,000 miles with an acceptable rate of failure on the original fill, that 100,000 miles is what lifetime fill means, and it's past the extended warranty and goodwill limit, meaning a failure after that is no longer the manufacturer's responsibility. Every word in that sentence is doing work. Acceptable rate of failure. Acceptable to whom? Not to you. You own one transmission, and if yours is the acceptable one, your acceptance rate is 0. 100,000 miles happens to land just past the warranty and any goodwill window, and lifetime was a maintenance cost and marketing decision, not a discovery that the fluid had become immortal. And here's why you never got to weigh in. When they take the dipstick away and print lifetime in the book, they haven't just skipped a service. They've removed the decision from you. You can't check the fluid, you can't see the fluid, the book says there's nothing to check, and the service advisor is reading from the same book. You were never told we've decided this component's design life is 100,000 miles and after that it's your problem. Which is a defensible engineering position, honestly stated. You were told the opposite. You were told there was nothing to do. The word chosen for that was a word that means forever. That's the whole trick, and it cost them nothing to run. Lower advertised maintenance costs on the window sticker. A cleaner ownership cost comparison against the competition. Fewer warranty period service visits. And the bill lands on somebody who bought the car at 70,000 miles and has no idea any of this happened. You know the sentence now. Next time you read lifetime in a maintenance table, you'll automatically ask the only question that matters: lifetime is defined by whom and ending on whose bill. Step back from the transmission for a second, because there's a bigger habit in here worth taking with you. What we've lost isn't really the dipstick, it's the assumption that you're the one making the call. A maintenance schedule used to be a conversation between the people who built the thing and the person who owned it, and you were expected to bring judgment to it. Your climate, your loads, your traffic, your plans for the car. Now it arrives as a finished verdict with the reasoning removed, and the reasoning is the valuable part. Judgment is a skill, and like any skill it atrophies if nothing asks you to use it. Nobody can hand you a single correct number for your car, because the honest answer depends on facts only you have. What you can build is the ability to ask the right 4 or 5 questions and reason your way to an answer you can defend. That's not paranoia about manufacturers. Half of what they tell you is straight, and modern fluid genuinely is far better than what we had 30 years ago. It's just knowing which parts of the advice were written for your benefit and which parts were written for someone else's, and being willing to do a little arithmetic before you accept either. So here's the procedure. Not a rule of thumb, something you can actually run on your own vehicle. Question 1. What does the transmission's manufacturer say as opposed to the vehicle's manufacturer? Those can be different companies with different answers, and the one who built the gearbox has no marketing reason to say never. Question 2. Is your driving honestly severe? Short trips, city traffic, hills, heat, roof racks, a trailer of any kind, gravel or salted roads. Remember that 6% of drivers think they qualify and 62% actually do. Be truthful, because heat is exponential and this question carries more weight than every other one combined. Question 3. What's the fluid's history and what's the odometer? Documented services put you in maintenance mode. Unknown. History past 100,000 miles puts you in careful mode, drain and fill only, inspect the magnet, no machine. Question 4. How long are you keeping the car? If you're selling at 80,000, the factory schedule is fine and it was designed for exactly you. If you intend to see 200,000, you are outside the design assumption and the schedule was never written with you in mind. Then act. In maintenance mode, on a conventional automatic, a drain and fill every 50,000 to 60,000 miles, with the pan and filter done when the design allows, is a defensible interval that no transmission builder would argue with. Severe use, pull it in toward 30,000 to 40,000. CVTs, tighter again. Use the exact specified fluid, set the level at the specified temperature, and keep the receipts. The whole program costs you a few $100s a decade, and it buys you the thing nobody sells, knowing. And if you're already at 180,000 on original fluid and it's shifting cleanly, don't panic and don't let anyone talk you into a high-pressure flush. Drop the pan, look at the magnet, put fresh fluid in, and drive it. Fresh fluid never killed a healthy transmission. It's the worn-out ones that we're leaving anyway. Here's what that actually looks like a few years from now, and it's deliberately unspectacular. You're at 140,000 miles. The transmission shifts the way it did when you bought it. There's a folder in the glove box with 3 receipts in it. Nothing dramatic ever happened. No rumble strip vibration on smooth pavement at 45 miles an hour. No service advisor explaining that unfortunately these do sometimes go and it'll be around 6,000. The whole reward for this is a bill that never shows up, which is the least satisfying kind of win there is and by far the cheapest. Now, I want to hear from the people who are going to tell me I'm wrong about this, and I know exactly who you are. Because you've been in this trade longer than I have, and you've watched 3 flushed transmissions go bad in the same month. You think the lifetime fluid thing is overblown internet panic, and that modern synthetic really does go the distance in a car that isn't abused. Come tell me. Bring the specifics. What transmission, what mileage, what the pan looked like, what happened afterward. I'd genuinely rather be corrected in public than be confidently wrong in private, and this is one of those subjects where the guys with the most hours often disagree with each other, which usually means the truth is more conditional than either side wants it to be. And for everyone else, the question I actually want answered, what's on your odometer, what's in your transmission, and has it ever been changed? Just those 3 things. Make and model, the mileage, and whether the fluid's original. I read the replies on these and I'll answer as many as I can get through because the pattern that comes out of a few hundred of those is worth more than any single service bulletin. If you've had one fail, tell me what it cost you and what the shop said caused it. If you've got 250,000 miles on a never-touched gearbox, say so. That's data too, and it deserves to be in the pile alongside the horror stories rather than left out because it's inconvenient. If any of this changed how you're going to think about that maintenance table, subscribing costs you nothing and it means the next one finds you. Because there's a thread in here I deliberately didn't pull today. Every time I look at sealed transmissions, I run into the same question underneath them, which is why the coolers are as marginal as they are. A heat exchanger that drops fluid temperature by 10 or 20% is not a serious attempt at cooling anything, and it's sitting inside a radiator that shares its fate with your engine coolant, which is its own can of worms. There's a reason for that design, and I don't think it's laziness, and I don't yet have it nailed down well enough to explain properly. When I do, that's a video. Until then, check the magnet, not the color. Look after it, and it'll look after you.